Right, so we'll talk about two main topics today. We'll talk about controllers in the context of the model view controller design pattern, and then mocks as a mechanism for simplifying testing. Right? So being able to replace or simulate things that we don't really care about. For instance, if you want to test an algorithm, and that typical algorithm might be usually in real life might typically be accessing some network, or might be accessing some database, or might have to do some heavy interaction with a user. It's very inconvenient to test it because you need the database, you need the network, you need an actual user. But you really care about testing the algorithm all by itself, right? And the fact that it needs a database and the fact that the data is accessible through a network, that's irrelevant, right? It's just a particular means of storing some data or retrieving the data. If I could replace those things, if I could replace the database, if I could replace the network, if I could replace the user, I could focus on testing that one algorithm, yes? Which is really what we want to test. So what mocking is, right? So the whole point of mocking is to try and simulate those things that do not pertain, or that is not our focus for our test. Right, so we try to isolate our algorithm, right, and make it independent of other things, like depending on a database, depending on a network. If I could simulate the database, right, I can now test my algorithm without actually needing the database. Make sense? Right. So we'll talk about mocking. Controllers, again, it's in the context of the model view controller. Which did Vito go model view controller? I might have just a little bit more to say about that. Let's real quick, the model view controller is a design pattern, right? Like we discussed last week or so. Design patterns are patterns that folks have identified as they have worked for years, decades, over many lifetimes, right? People just documenting their experiences and then making it available to us so that we don't have to reinvent the wheel, yes? And model view control is just one of those patterns that has been very, very successful in implementing certain types of applications, in particular user interface applications where there's heavy interdependence with an actual human being interacting with an application, right? So it has been very successful and implemented by many different frameworks out there. In particular, the Java 2EE Enterprise Edition Java version, which introduced Java Server Pages, servlets, EJBs, and all these different ideas that are built on this particular design pattern, right? .NET did the same thing, right? They also implemented this framework that was based on this design pattern, and the idea was to apply a principle, a more general principle, which is a separation of concern, right? Meaning, if we could identify what are the concerns of different buckets in an application, of the different parts of a system, right? And we could separate them, and each one of those pieces could do its job very, very well, right? It'll be easier to then go on and have them talk to one another, right? So after having built many different user interaction applications, folks found this pattern that worked very, very well. That if we find that most of the artifacts that folks would build would deal with three specific concerns, right? One of them was to represent the model, to represent the data, right? That the system was dealing with, what the structure of the data was, what the relationships were between these objects, whether it was using linked lists or arrays, if this were being stored in a database, which tables it was being. Were they being mapped, whether they were linked together by foreign keys and primary keys. So all that is a whole bunch of concerns, right, on how to best represent the data, okay? And it's not concerned at all on how am I going to represent it for the human being. So here's a human, right, and they just want to see, some graph, right, or some whatever, and so the concerns of representing this for a human being for consumption at from their frontal cortex is a complete different set of concerns, right? The colors and the white space and how which color scheme and how I'm going to lay it out for the humans to look at. It's a complete different set of concerns, right? If I have here x, y, and z with values 1, 2, and 3, the model is going to do its best to decide how it's going to store that. Is it going to be integers, floats? What am I going to do? Is it going to be a tuple? Is it going to be an array of three elements? That's a completely different set of concerns, right? And it's completely oblivious on how they're going to be rendered, right? The view could decide that, the best way to represent that for my particular human being is a bar chart, right, with 1, 2, and 3. Or somebody might say, no. The best way to represent that is with a pie chart. Yes? And so the concern of deciding that, I'm going to choose this view or that other view, right, it's a completely different set of concerns on how I'm going to store it. And they're not related to one another, right? So now I'm free to evolve my view without affecting having to evolve the model. Yes? So separating these concerns allows us to apply our best effort at making the best model possible without concerning ourselves with how is it going to be rendered. Make sense? For this, it's a whole set of technologies, HTML or graphs or whatever. In between, we have here a way for these folks to, like the glue between these two worlds, right? The model contains not only the raw data, right? It always typically includes all sorts of methods or functions or some algorithms that affect that data, that do all sorts of transformations, computations on that data. Yes? If it's integers, it adds them. If it's a flight number, then I can book a flight. I can check in. I can check in my bags. Whatever. All the algorithms that go along with that data. Now somehow, as the user interacts with this UI, right? Somehow we need to make the mapping of how do that event or stream of events, right? The user clicks and drags and types at the keyboard, and we need to somehow convert all that stream of human events as we use our meat sticks and we interact with the keyboard. We need to convert that into a stream of events that manipulate this model. And the controller is exactly what that does, right? The controller is the interface between these two that takes in human input, right, and somehow map it to some actions that manipulate the model. And it's also responsible for retrieving the data from some model, right, and then passing it to the view and deciding what it is that the user sees next. So the controller is responsible for sequencing, right, and mapping these actions in between. And this has been very, very successful for the last couple of decades at implementing these types of UI driven applications. First, it was mostly server side. Now today, it has become very client side, and again, still very, very successful. Anyway, so the model. The model is the domain information with the data and any data and also any actions and methods that manipulate that data. View renders it for the human being, and controller is the glue between the two. The controller decides how and when the model is going to be used. Oftentimes, the way we represent this, it's trying to eliminate things such as redundancy. Remember, redundancy breeds inconsistency. But oftentimes, for rendering purposes, we don't really care how we stored it. Right? This might be very hierarchical, objects within objects within objects. Is very deep, is very complex. Perhaps the view just wants to see just a very shallow representation that I can just display it in one single go. So there might be some conversion between these two layers to make it more convenient for the view to represent. So the control can do all that conversion between these two worlds and interacts and does the mapping between these two layers. Right, so the model provides operations. The view, it's oblivious on how, the view has no idea on the sequencing. It's only concern is dealing with this human being, right? At this very low bandwidth human being, and converting that low bandwidth into a very high bandwidth, a computational model. It doesn't know where to go, right? If you click on a particular button, right? Its only responsibility is not to decide what to do or where to navigate to or anything like that. It's always delegated to the controller. It says, controller, the user just clicked on checkout. What should I do? Right? So the controller is the one who decides all that and says, oh, you should now navigate to the checkout. Well, let me check to see if they have actually put anything in the shopping cart. If they haven't, well, no, don't go anywhere. If they have, well, let's go, and has all that logic. Yeah. For your assignment this week, you're going to be building a Marble Solitaire controller, right? And the model and representing all that data. And it's the controller who's going to be determining what to do with the user input as folks choose to move one marble from one location to another location. What operations to do to actually move the marble and make sure that you're not moving a marble from one location into another location where there's already a marble, right? So all that business logic, all that rule will be encoded here, and also decide how to display this and pass in the data for the view to render it. So it's going to capture the sequence and determine what by the controller. Also, we're going to be looking at a what it's called a synchronous controller. We're going to distinguish today between a synchronous controller and asynchronous controller. The synchronous controller is going to have full control of what happens next, right? It knows that this is a sequence of events, and you're not allowed to deviate, right? Synchronous meaning I say something, you respond, and then I say something, and then you respond, right? And it's a very well choreographed interaction between two folks. Right? If you're on the phone, it's very choreographed. Right? I speak, and then you speak, and then I speak, and then you speak. Hopefully, we're not interrupting each other. But as opposed to an asynchronous communication, where I send you something, right, and you're free to consume that at any time later at some point, yes? And it's interrupt-based, yes? I receive an interruption from you from a messaging, and I can deal with it at any time. And when I respond, I send back another interrupt, and then you can consume it at your own particular pace, yes? So the two architectures are very, very different on the timing and the sequencing. The assignment that you're going to be working on mostly is going to be synchronous, right? You ask for the controller prompts you for a move, you give it the move. The controller acts on that move, and then it gives you another, and then prompts you again, yes, right? And then you give it another move. Right? It's very well choreographed, and it takes turns, as opposed to a synchronous controller where the user can just click and drag and send all sorts of events to some centralized controller, and the controller needs to make sense out of all these interrupts that the user is clicking and free to do all sorts of things at different times. Yes. So we'll talk about the two types of controllers, but for your assignment it'll be mostly a synchronous controller, right? The controller decides what happens next, not the user. Right? The controller says, well, now your turn, and then it's my turn. All right, so let's talk about handling input.